Good morning, class. My name is Miss Nyrider. As you all know, and today we're doing experiment 3, the determination of a chemical formula. As you all know, we're going to be talking about elements and how they combine in fixed ratios to form compounds. For example, we have C2H4, which we have 2 atoms of carbon, 4 atoms of hydrogen. And does anyone know what an empirical and molecular formula is? No? No one knows? Okay, so we have our molecular formula here, which is our true formula. We have 2 atoms of carbon, 4 of hydrogen. This is our empirical formula, which would be simplified into 1 carbon and 2 hydrogen. Okay, guys, and I just want to go over the objective of the experiment. In experiment 3, we are to synthesize and determine the empirical formula of the product in a reaction of zinc metal with solid iodine, and we're also going to determine the formula of an unknown hydrate. And each of you all will have different unknown hydrates. There are 2 things I want you all to remember within this experiment: that a mole is a unit of chemistry that represents an amount of molecules, ions, or atoms. And we also need to remember Avogadro's number, which is 6.02 times 10 to the 23rd. And I also want you all to remember that the mole ratio, we're going to have to use that in the end to find our empirical formula within the experiment.
Like, how do we even do this experiment? Like, how do we even start?
Well, first we have to weigh the beaker, then we have to weigh the beaker with zinc in it. Then we weigh paper, and then we measure out iodine and put it on the paper, and then weigh them both together. Then we add acetic acid to the beaker with zinc in it. Then we swirl the beaker until it becomes colorless. Then we decant the solution into a beaker, add acetic acid to beaker with solid zinc, wash the zinc, dry the zinc, heat the moist zinc, heat again, and then weigh the remaining zinc.
That sounds just like way too many steps. Like, why can't we just do all that and then weigh our final product and then be done for the day?
Well, if we don't weigh it first, then we won't have an accurate number for how much of the product we have.
Okay, so if we have to weigh everything out, then we get the final product and then we're done, right? Like, we can go eat lunch.
No, actually, that's just part A.
No.
This is part B. We weigh the crucible, weigh the unknown hydrate, cover crucible and heat it, listen for crackling, then we cool the crucible, weigh it again only after it's cooled. Heat the crucible again, repeat the process of cooling and weighing it. Then we need to find the anhydrous salt, which is unknown, and so we clean the metal spatula by adding it to a solution with HCl in it. Then we dip it in the flame to make sure it's completely clean, pour some of the remaining unknown hydrate on the spatula, stick it in the flame, and if it's red, then we have strontium chloride, and we're done.
Finally, so if we get red, then we're done.
Yep, we're done.
Finally.
Yes?
Ms. Nyrider, what instruments will we be using in this experiment?
That's an excellent question. We're going to use a 50 milliliter beaker, a 100 milliliter beaker, a hot plate, an unknown hydrate, zinc metal, which will be powdered, iodine, a 0.2 molar acetic acid, crucible and a cover, Bunsen burner, iron ring, and a ring stand, and wire gauze. Any more questions?
Nope, I think that's good.
Good.
I have a question.
Yes, ma'am.
Is this experiment dangerous?
Well, not technically, but if you do not follow the safety procedures set, for our laboratory, it can be. We want to make sure that our gas that we open to start the flame, we want to make sure it's at adequate level and not too high, and make sure you set the burner so that way the flame isn't too high, because that could become very dangerous.
Okay.
Class, I just want to make you all aware while you are decanting within the experiment, I want to make sure that everyone is using the pipette to only get the liquid out of the beaker. We do not need the solid mixed in, or else that will skew our results.
Miss Nyrider, I finished the experiment and I've gotten all my results, but I'm still unsure on how to find the empirical formula.
Reagan, I taught you this the other day. Is anyone paying attention to me in this class? Does anyone know how to find the empirical formula?
Ms. Nyrider, I think I know how to do it.
Of course you do.
Do you care to come up to the front of the class and explain to the class how to do this?
Sure. Okay, so the first step we took the mass of our iodine weighed in grams and divided it by the molar mass of atomic iodine. And this gave us 5.0 times 10 to the negative third moles of iodine. The next step, we took the mass of the beaker with dry zinc in it and subtracted the mass of the empty beaker and got the remaining zinc, which was 0.59 grams. Then after that, we took the initial mass of zinc and subtracted the mass of zinc remaining and got 0.17 grams of zinc reacted. Then the next step was to take the grams of zinc reacted and divide it by the molar mass of zinc. And this gave us 2.6 times 10 to the negative third moles of zinc. The third step was to take the moles of iodine and divide that by the moles of zinc. This gave us 1.9, which we rounded to 2 to give us the empirical formula of ZnI2. Next, for our calculations in Part B, we took the mass of water and divided it by the molar mass of water. This gave us 1.05 times 10 to the negative 2 moles of water. The second step was to take the mass of the anhydrous salt, divided it by the molar mass of the anhydrous salt, and this number was 1.70 times 10 to the negative third. Our last step in Part B was to take the moles of water and divide that by the moles of the anhydrous salt. This gave us 6, the number 6. That left us with SrCl2 times 6H2O.
Great calculations, Molly, but I just wanted to add and make sure the whole class was aware that we need to make sure to put all of our units and all of our observations on our results, because this might mess us up in our conclusion, and we need to make sure every observation, every unit is written down, so that way they're very helpful and not useless. Yes?
Miss Mayrider, during my experiment, I accidentally spilled some during Part B. So what do I need to do for that?
That'll be okay. It will skew your results. It's going to make them a little bit less than what they should be, but I just want to make sure that you're aware and that I'm aware that you did spill some things. Make sure you note that in your observations, note that in your conclusion, and that way I can get an idea when I'm reading over your results and your conclusion that I can kind of be aware of that and then base it off of that.
Okay, good. I will do that.
And I also wanted to make a note for all the class while I have your attention. I want to make sure that everyone uses your handout and your textbook in your conclusion of the results. Make sure you cite them correctly. And then I just want to wish you all a good afternoon. Make sure you have your pre-lab written. Come with me to any questions. Your handout is on Tigernet.